Okay, here we go. For question number 1, I'm going to take the top two equations. I notice here that z has a negative z and a positive z, so if I take and I add these two top equations together, that's going to result in 7x minus y is equal to 8. Okay. Then if I multiply this middle equation by 2, that will give a positive 2z right here, which is going to cancel with that negative 2z. So multiplying this middle equation by 2 and then adding it to this bottom equation, 2 times 3 is 6, add that to 3, so we get a 9x there. 2 times 2 is 4y plus 4y is a positive 8y. And then 2 times the negative 4, or 2 times negative 2 is negative 4. When you add that to 5, you get 1. So this equation right here is a result of adding the middle equation and the bottom equation. So now looking at this, we need to eliminate, it looks like the y variable is going to be easiest. So if I multiply top equation by 8, that's going to turn this into 56x minus 8y is equal to 64. And over here we have 9x, the bottom equation didn't change. So adding this now gives us 65x equals 65. So x is equal to 1. Now if we go back up a step, taking this value of x and using this equation here, or either one of these would work, but I'm going to use this equation. I know the value of x is 1, so 9 times 1 is 9. 9 plus 8y is equal to 1. If I subtract 9 on both sides, I get 8y is equal to negative 8. So y is equal to negative 1. Now taking both of these values, the value of x and the value of y, choosing one of these equations, the original equation, I'm going to choose this bottom equation again. X is 1, so 3 times 1 is 3. Y is negative 1, so 4 times negative 1 is negative 4. This is going to allow us to solve for z. This is going 3 minus 4 is negative 1. If you add 1 to the other side, you get negative 2z is equal to 6. So z is equal to negative 3. Solution then being x equals 1, y equals negative 1, z equals negative 3. For question 2, I notice right here that negative y, positive y, those would cancel. So if I take and combine these top two equations, that's going to result in 3x plus 9z is equal to 0. Then if I take this bottom equation here, or sorry, this middle equation, I need to eliminate y again since I eliminated it here. So if I multiply this middle equation by negative 4, this is going to be negative 8x. Combined with that, that's negative 6x. This is going to be the negative 4y, which will cancel with the positive 4y. Negative 16z minus 2z is negative 18z. And that equals 0. Okay. Now if I took and multiplied the top equation by 2, that's going to be 6x plus 18z equal to 0. Negative 6x minus 18z is equal to 0. Adding these up produces 0 equals 0, which means there are infinitely many solutions. So what we now need to do is set our parameter. Okay, z is going to be equal to t. Now, if we go back to this middle step here, we need to write x equals in terms of z so that we can change z to t, and then we'll have x in terms of t. So if I take this top piece here, for example, 3x plus 9z equals 0. 3x plus 9z equals 0. If I subtract the 9z, we get 3x equals negative 9z. Then dividing by 3 gives x equals negative 3z, but z is equal to t, so we say that x is equal to negative 3t. Okay. Now we're going to go back up to one of these original equations. I'm going to choose the middle equation, but instead of the x and the z, we're going to make substitutions in terms of t. So this middle equation here is 2 times x, so that's 2 times negative 3t, plus y, plus 4, and then z is equal to t, and that equals 2. So this is negative 6t plus y plus 4t is equal to 2. Negative 6t and 4t makes negative 2t plus y is equal to 2. Adding 2t to the other side is going to give us y equals positive 2t plus 2. So now we have our value of y. Here we have our value of x. Here we have our value of z. So in an ordered triple, x comes first, y comes second, okay. So looking here, if I multiply the top equation by 3, the bottom equation by 2, this is going to be 24x minus 6y is equal to 15. Negative 24x on the bottom plus 6y is equal to 14. This leaves us with a statement 0 is equal to 29, which is not a true statement. There's nothing left to solve for because the variables canceled, therefore there is no solution to the system of equation. Okay, question 4. This is a system of nonlinear equations. This equation here is actually a parabola. This equation bottom equation is linear, so it graphs a line. So we have a line that is possibly intersecting with a parabola. So the method I'm going to use is the substitution method. I'm going to add the y to the other side of this equation here. So it's going to be x is equal to y minus 3. Actually, you know what? To make this a little bit easier, I'm going to substitute, I'm going to get what y equals. Okay. So I'm going to rewrite this in terms of y. This equation is going to be y equals x plus 3. It'll be easier to make a substitution of y. If y equals x plus 3 here, then this y also equals x plus 3. So I'm going to take x plus 3 and substitute it in for that y. So that top equation is now x squared. Instead of plus y, it's plus x plus 3 equals 9. If I subtract 9 to get it equal to 0 and try to factor, this becomes x squared plus x minus 6 is equal to 0. This factors into x plus 3, x minus 2. Solutions therefore are x equals negative 3 and x equals 2. And since we have two different x values, we're going to be getting two different y values for each different x value. So if x equals negative 3 and I substitute the negative 3 in for x, then y equals 0. So the solution is negative 3 comma 0 for that x value. If x equals 2 and I plug it in for this x, then y equals 5. So this solution is 2 comma 5. Okay, partial fraction decomposition. There were a few different cases. This happens to be case 1, where the denominator is a product of distinct linear factors. So the form of the partial fraction is a over x minus 5 plus b over x plus 2. This is the form of the partial fraction. What we need to do now is multiply both sides by the lowest common denominator, which is x minus 5 times x plus 2. So if I multiply here by x minus 5 and x plus 2, denominator just cancels and we're left with 7x plus 7. Now if we multiply this side by x minus 5 and x plus 2, and when I take this lowest common denominator and multiply it to this term, the a over x minus 5, the x minus 5's would cancel, so we're left with a times x plus 2. Now when this lowest common denominator multiplies to this term here, the x plus 2's would cancel, and we're left with b times x minus 5. Now we need to get rid of parentheses here, so I'm going to distribute the a and distribute the b. And now I'm going to group like terms together. These two terms both have x's, so I'm going to group those together. And then 2a and the negative 5b, those are constants because they have no variable. So now here, both of these terms have an x, so I'm going to factor out an x from both of these terms, but I'm going to factor it out and put it behind. Now the equal sign means that both sides of the equation are exactly equal to each other. Okay? Since we have a variable here and the same variable here, that means what's in front of the variables have to equal each other. Those are called the coefficients. So if we have a 7 in front of the x and a plus b in front of the x, if both sides are exactly the same, that means that a plus b is equal to 7. Now the constant on the left side is 7. The constant on the right side is 2a minus 5b. Those two constants must equal each other because the two sides equal each other. So 2a minus 5b is equal to 7. Now we need to solve the system of equations. If I multiply the top equation by negative 2, this becomes negative 2a minus 2b equals negative 14. Here we have 2a minus 5b equals 7. Adding this up gives negative 7b equals negative 7, so b is equal to 1. Now a plus b is equal to 7. If b equals 1, that means a has to equal 6. So we go back up here. We replace a and b with what their values are. Final answer is 6 over x minus 5 plus 1 over x plus 2.